Hello friends, today we will discuss one of the important concepts in physics, resultant force or net force. Whenever a word comes resultant force, then I think very simple. Suppose I took one of the problem here. Suppose on the surface of a table, the top of the table I placed one block of mass 5 kg and I applied two forces on it along this 10 Newton, and in backward direction I have applied suppose 5 Newton. So I have to find out the acceleration of this block. Again, how I will find the acceleration of this block? Important formula, Newton's second law of motion, F equals to ma. And what is F here? Net force or resultant force. So I will find the net force on this block. It is very easy, 10 minus 5, because they are opposite. So one force is 10, other is 5. So what will be the net? 10 minus 5 equals to m into a, means 5 into a. Finally, what will be the a? 1 meter per second square. But again, acceleration is a vector quantity. So what will be the direction? It will be along the direction of 10 Newton force, because 10 Newton force is greater. So that is basically net force. I took one of the simple example of net force. Okay, second example I am taking. Suppose the same block is there now. Again, it is placed on the surface of table, and this time again we apply two forces. 3 Newton, another force is 4 Newton. Both are perpendicular to each other. 4 Newton. They are making 90 degree. Suppose the block or the mass is 5 kg. What we have to find out? We have to find out the acceleration. What will be the acceleration of this block? Again, we will apply the formula F equals to ma. What is F here? What is F here? So again, F is net force. Just now we have discussed F is net force. So what is the net force now? 4 plus 3, 7. No, it is not like that. We have to calculate the net force. So I will put this force F into vector form. So what will be this force? 3I, because it is along x-axis. Second component 4, it is along y-axis. So what will be the magnitude of this force? I can write like this, magnitude, and it will become 3 square 9 plus 4 square 16 and 5 Newton. So what I can apply in this formula? What is net force now? So F, what will we put the value of F? 5 equals to m, 5 into a, and finally what will be the acceleration? 1 meter per second square. The important thing, again acceleration is a vector quantity, so what will be the direction? So how we can find out the direction? Very simple. First we have to find out the direction of force. So what is force here? Just you see here 3i plus 4j. So what I can write? This is 3i, and along this if I plot, this is my 4j. If I plot like this, this will be 4j, 4 Newton. So 3i plus 4j, as per the triangle law, we can find out the resultant force. So this is basically 3i plus 4j. 3i plus 4j. So now I can find out the angle here. What is the angle or the direction of this force? Because along this direction only the acceleration will work. So what will this acceleration? Tan theta. So tan theta will now become, tan theta will become now 4 by 3. Because 4 is perpendicular, 3 is base. So theta will be tan inverse 4 by 3. And finally, I can find out that the direction of acceleration will be along the direction of this force. So I can say the value of theta will be tan inverse 4 by 3. So basically net force or resultant force is very important concept in physics. Net force, wherever it is required. If suppose you want to discuss the motion of lift, here also we can apply this motion of lift. We will apply this net force. We can find out. Suppose one person is standing inside the lift. Okay, this is the person and it is standing inside the lift. So now suppose the lift is moving in upward direction with acceleration a. It is moving upward direction with acceleration a. So again, what are the forces acting on this man? What are the forces? One force will be its own weight, mg. Another force will be normal reaction, that is r. So what will be the equation? Again we have to apply the equation F equals to ma. So what is the net force on this? Now the important thing, net force on this man, because upward force is R, downward force is mg, and lift is moving upward direction. So what is the net here on this man? Net force R minus mg. So I can write it R minus mg, and that will be equals to mass into acceleration. So m equals to a. So what I can find out, R. Finally it will become m into g plus a. So basically from this you understand that how to find out the normal reaction in case of a lift, while lift is moving upwards or lift is moving downwards. So if you understand the concept of net force, you can easily solve this. One more example, if I am taking net force, suppose, oh sorry, just a minute, okay, no problem. Suppose one block is suspended with the help of a thread, huh? So now what is the force, what is the net force on this block? So suppose the mass of the block is m and the tension T. So downward force will act mg. So what is net force? F equals to ma. We can apply here also, F equals to ma. But what is net force on this? Upward T, downwards mg. So I can write like T minus mg. What is the block of acceleration in this case? Because acceleration is, so because block is in rest or stationary, there is no motion, so it will be 0. So I can write T equals to mg. So like that we can derive the equations by using net force. Wherever you have to apply the net force, you can easily apply it. So one more example, if I would like to take, suppose a pulley is there, and across this pulley I suspended two weight here. Suppose it is 5 kg, and along this suppose I suspended a weight, mass of 10 kg. Again, this is a string, you have to keep in mind, right? So again, if I have to make certain equations of this, suppose this is fixed with the help of this, so I have to write the equations here. So downward, what will be the force? 10g. Upward, there is a tension T. Downwards, if you write here, 5g. Upward, there will be T. You know that if the same string is there, then the tension remains here. So finally, suppose this object is not going to be stationary, it is moving. So in which direction it will move? Because 10 kg is larger, so it will move downward direction. So now suppose it moves with the acceleration a. So we have to write the equations of these two blocks. So if it is moving downward a, then but naturally it will move upwards with acceleration a, because they are tied with the same string. So if I write this equation, so right, suppose this is my block A, this is block A, and this is my block B. So you have to write the equation of block A. So how I will write? What is net force in this block? You have to first calculate the net force. So net force, there are two forces acting on this block, 10g downwards, T upwards, but the 10g is greater because the finally block is moving downwards. So I will write the equation 10g minus T equals to F equals to ma. Which formula we have to apply? Always we have to apply the formula F equals to ma. So F, what is net force? 10g minus T. But I will write F into m into a. So what is m here? 10 into a. So this will be the one of the equation. Similarly, I can make the equation for this block also. Now, in which direction this block is moving? Upward. So which force is greater, T or 5g? T. So how I can write? T minus 5z equals to m into a. It means 5 into a. So like that, this will be equation 2. So by solving these two equations, I can find out the value of acceleration or whatever. So like that, I will add these two equations, add equation 1 and 2. So finally what I will get? 10g minus 5z equals to 15a. So finally, what will be the acceleration? A equals to 5z divided by 15. So like that, I can find out the value of z is 10. So it will become 5 into 10 divided by 15. So 10 by 3 meter per second square. So like that, we can calculate the net force. So I think you have understood how to calculate the net force.